Thank you very much for having me. My name is Nils Schorndorf, and I'm the new postdoc at the Research Group for Earth Observation at the Heidelberg University of Education, which is led by Alexander Sigmund. And I've recently taken over the lead of our GIS station, which is our specialized competence center for digital geomedia. And our three pillars of capacity building together form our UNESCO chair on Earth observation and education of World Heritage and Biosphere reserves. So first, there is the GIS station, which is our unique competence center for digital geomedia and combines the research and teacher training with hands-on workshops for students. Then second, there is the so-called Gecko Lab, which is our research and school lab, bridging the gap between fieldwork and lag analysis. And it helps students and teachers to use hands-on experiments to understand the science behind environmental change. And third, the B&E Center, which is kind of our university-wide hub for sustainability, connecting experts from many different fields to give all our projects a strong scientific and strategic foundation. And as you can see on this map here, we maintain an extensive web of partnerships, including UNESCO and Erasmus partners, but also many research projects and so on. And since the founding of our GIS station back in 2010, we've moved through several key development phases where we mainly focused on the creation and refinement of so-called EO education tools, such as BLIF or Geospective. And this was also accompanied by numerous PhD theses to really measure exactly how students develop system thinking and special competencies when working with real satellite data. And our work here at the GIS station centers on three core technological competencies. There's remote sensing and satellite imagery to translate the complex satellite data into understandable information, to analyze global environmental change, and GIS to enable the learners to use these digital maps for special analysis and other problem solvings. And finally, we have the mobile geo tools to bridge the gap between the digital data and the real world. So through kind of GPS-based fieldwork and mobile applications. And to give you some numbers, since our start almost 16 years ago, we've conducted more than 1,000 events where we reached more than 25,000 students and about 3,000 teachers. And to look a little bit at these two interactive e-learning platforms. So there is on the left Geospective, which serves as our adaptive e-learning hub, focusing mainly on current and relevant environmental topics, such as, for example, climate change or land use. And on the right-hand side, you can see BLIF, which is our web-based tool for the analysis of satellite data, allowing the users to create, for example, true color or false color visualizations or calculate environmental indices such as the NDVI. And over the years, we have also developed some virtual learning environments like the virtual Gecko Lab and the virtual GIS station, which are basically digital versions of our real labs that students can visit from basically anywhere in the world, and they can try out experiments and explore in a safe and interactive way. And this is also always a huge highlight for the students and gets them excited. And looking ahead to 2026, we will, of course, continue to improve these e-learning environments, continue our year-round school workshop. We just hosted a youth academy, and we will conduct further secondary teacher trainings in November. And with projects like in German, it's GeoZukunft or GeoFuture and AIEO, we are trying to get the artificial intelligence into Earth observation and education. And with that, I hand back to Mark.